Working on the second page, tangent of u is equal to 5 over 12 in the third quadrant. So we're going to start off with the third quadrant. Tangent is y over x, so that would be 5 here, 12 here. They're both going to be negative because they're both in the third quadrant. So 5, 12, 13. Then it says find sine of u and cosine of, or sine of 2u and cosine of 2u. So if I look at this, sine of u is going to be negative 5 over 13. Cosine of u is going to be negative 12 over 13. So sine of 2u can be rewritten as the formula 2 sine of u cosine of u. So 2 times negative 5 over 13 times negative 12 over 13, which ends up giving us positive 120 over 169. Cosine of 2u is going to be cosine squared u minus sine squared u. Now there's multiple versions of this, but I prefer this one for these types of problems. So I'm going to write this as negative 12 over 13 squared minus parentheses negative 5 over 13 squared. Now, if you see that they're both negative, when you square the values, they will become positive, but it does not change the subtraction in between. So this will be 144 over 169 minus 25 over 169. So that's going to end up giving us 119 over 169. And there are my two values. Now with this next group, for numbers 12, 13, 14, the interval is from 0 to 360. That also means that we're not including 360, so we do not need to worry about that value. That means that these are going to be in degrees, while the remaining bunch are going to be in terms of radians. So you need to be aware of that. So the first group, I'm going to add root 3 to both sides. So I get 2 cosine of theta is going to be equal to root 3. Divide everything by 2. And I end up getting cosine of theta is going to be root 3 over 2. Now, this is going to be the value 30 degrees and 330 degrees. That is where cosine is going to be the value root 3 over 2. 30 degrees in the first quadrant, 330 in the fourth quadrant, because that's where else cosine is positive. Next, I'm going to write down 6, I'm going to add 3 to both sides. I get 6 sine squared theta is equal to 3. Divide everything by 6. I get sine squared theta is equal to 1/2, right, which 3/2 reduces down to. I'm going to square root both sides, and I get the following. This is going to leave me with a sign, but when I do a square root to both sides, I need to remember a plus and minus. So this is going to be plus or minus square root of 1 over square root of 2, which is another way of saying 1 over square root of 2. Now this still might not be familiar, so we're going to multiply the top and the bottom by root 2. So we get root 2 over 2. So it's going to be plus or minus root 2 over 2. So that means that it's not going to be just in the positive quadrants, but also the negative quadrants as well. So 45 here, 45 here, 45 here, 45 here. So theta is equal to 45 degrees, 135, 215, 225, and 315. And that's all within 0 to 360. And those are my answers. I'll box in my other ones. Don't really need to, though. Anyway, so with this one, notice how there's a 2 theta here. So, and then there's another sign that gets in the way of kind of evaluating this problem. So I'm going to convert this to be 2 sine of theta, cosine of theta, because that's what that changes down to be, minus sine of theta, and it is equal to 0. Now, whenever you have multiple trig functions that are within an expression or an equation, you always want to try and get everything off to one side and then try to factor out anything that you can. So if we look at this, they both have a sign. So I'm going to take out a sign. So I'm left with 2 cosine of theta minus 1 equals 0. Now we have two conditions. Sine of theta is equal to 0. 2 cosine theta minus 1 is equal to 0. So I'm going to add 1. 2 cosine of theta is equal to 1. Divide both sides by 2. And I end up getting cosine theta is equal to 1/2. Now, over here, where is sine equal to 0? Well, that would be 0 and pi. Well, excuse me, this is going to be in terms of degrees. So 180 degrees. Now, when is cosine equal to 1/2? That would be 60 degrees and 300 degrees. So those are those values. Okay, now the following values are going to be in terms of pi. If you are not familiar with kind of the conversions between radians and degrees, or excuse me, these are going to be in terms of radians, not just pi's. So if I was going, let's say 315 degrees, to go to radians, you tack on a pi and put it over 180 degrees and then reduce that number, which would end up giving us, in this case, would be 7 pi over 4. But if you feel comfortable with radians, I would suggest just keeping with that. All right, these problems are going to get relatively difficult. There are going to be multiple steps, so if you need to pause the video, pause the video. So we're going to start off with cosecants, which yet again adds more confusion to things, but really we're going to treat it like we did with sine and cosine. Bring everything over to one side, and if you don't bring everything over to one side, you end up losing an equation, right? Because then you don't factor something that needs to be factored. I'm going to factor out a cosecant, and so I'm left with cosecant of theta minus 2 is equal to 0, and then have my two values. So cosecant of theta is equal to 0, and cosecant of theta is equal to 2. Now, I don't like dealing with things in terms of cosecant, right? It doesn't make sense to me. So what I'm going to do is I'm going to convert to be sine. And then so what I need to do to just change it over to sine is just do the reciprocal to the other thing. Well, the reciprocal of 0 is actually, well, it'll be 0 over 1, and it'll be 1 divided by 0, which is actually undefined. Now, there is actually no value that I could plug in for sine that would give me undefined, so that's actually out. Next one, so I would say sine of theta is equal to, well, reciprocal of 2, which is 1/2. And now I definitely know that value, which is going to be 30 degrees, and then 150. But remember, we're talking in terms of radians. So it's going to be pi over 6 and 5 pi over 6. Those are the values I need. Moving on. So I'm going to convert this cosine squared of theta because it does not match up with a sine. If they were both sines, that would be something else, or if they were both cosine. But since one is sine, one is cosine squared, I need to change one of those values. And since I know a direct changeover from cosine squared, I can rewrite this as 2 parentheses 1 minus sine squared theta, and then plus 3 sine of theta minus 3 equals 0. Distribute the 2, so I end up getting 2 minus 2 sine squared theta plus 3 sine of theta minus 3. Combine the like terms, so 2 and the negative 3. So I end up getting negative 2 sine squared theta plus 3 sine of theta minus 1. Now what I'm going to eventually have to do is I'm going to have to actually write it something that looks something like this. And I'm going to have to factor. So all I did off to the side was I said a is going to be equal to sine of theta. And we can do some direct comparisons or substitutions here to make things a little bit more easy to work with. So next thing, I notice that there's a negative in front. I don't like having a negative in front of a quadratic, so I always want to try and make that positive. So I can do that by just dividing everything by negative 1. So we get 2a squared minus 3a and then plus 1 is equal to 0. Now I'm going to solve this by doing factor by grouping. So I'm going to do 2 times 1. So that gives me 2. But then when you add, you get negative 3. So negative 3. So it'd be negative 2 and negative 1. So two numbers when I multiply, I get 2. But when I add, I get negative 3. So I'm going to rewrite 2a squared. But now I'm going to write the middle term as negative 2a. Write the other term as negative 1a. Now I always like to have a plus sign in between. And then plus 1 is equal to 0. So I converted that negative 3 to, in a sense, those two terms right there. Then I'm going to put parentheses around the first group and the second group. I'm going to take out a 2a, and I'm left with a minus 1. I'm going to take out a negative 1 so that the two parentheses do match up, right? They're both a minus 1. I'm now going to write this as 2a minus 1 with all the other stuff left over, and then a minus 1 is equal to 0. And then a is going to be equal to 1, a is going to be equal to 1/2, just to save some time. And then say sine of, I think this was theta, sine of theta is equal to 1, and sine of theta is equal to 1/2. Theta in this case, is going to be equal to pi over 2. And I think that's it. And then this is going to be pi over 6 and 5 pi over 6, going back towards that 1/2 again. And those are my values. Moving on to the next one. Now this one's a little bit different. Now I don't need to convert this because this is the only trigonometric function here. So I'm actually going to solve it out as I normally would just any other type of equation. So I'm going to get 2 sine of 2x is equal to 1, divide everything by 2, and I end up getting sine of 2x is equal to 1/2. Now we've done this already a couple times already in this review packet. But what I'm going to do here is I'm going to say, well, I'm going to say 2x is going to be equal to a. Again, just doing another type of substitution. And so I'm going to say sine of a is equal to 1/2. Now, so that means a is going to be equal to, well, we did this before in terms of degrees. I'm going to do this in radians, so that'll be pi over 6 and 5 pi over 6. Now, the tricky part here is since this is going to be 2 times that, we actually take each one of these values and then also get the coterminal angles to those one more time. So in a sense, I have to add 2 pi. But adding 2 pi is actually a little bit easier than you think it is. So all you do here is you take the denominator, in this case this is 6, we double it, so that would be actually 12 pi over 6, which is 2 pi, and then just add it to that. So add 12 pi to the top, so that's going to be 13 pi over 6, and then add 12 pi again, so that's going to be 17 pi over 6. So those are my values. Now, if I, in a sense, replace the a with the 2x, I now divide everything by 2. Yet again, this may seem confusing, but really all I'm doing here is I'm multiplying by 1/2, or dividing by 2. And so all I do here is I take the denominator and multiply by 2. So x is going to be equal to pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. And that is your answer. Okay. I think I'm down to the last 2 problems. Okay, good. All right, I'm going to convert this sine of 2x to be 2 sine of x cosine of x. There's another sine of x right there that I don't want to forget about, and then another cosine of x. This sine times sine, which actually ends up giving me 2 sine squared x cosine of x, bring the other cosine over to the opposite side, as I talked about before, is equal to 0. Factor out a cosine. So factor out a cosine. So I'm left with 2 sine squared x minus 1 is equal to 0. I'm now going to say cosine of x is equal to 0. 2 sine squared x minus 1 is equal to 0. Now we did this earlier, so I'm going to kind of jump back a little bit. If you want to see, I think I did this back in, let's see where I did this. Or maybe I didn't do this one. Maybe I'm just thinking about what I did in class today. Anyway, so I'll continue with that. So I end up getting sine squared x is equal to 1/2, square root both sides. And so I end up getting sine of x is equal to plus or minus root 2 over 2, which it simplifies down to. Okay, so then over here, x is going to be equal to, when is cosine 0? That would be pi over 2 and 3 pi over 2. When is sine going to be equal to root 2 over 2? That would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And those are my values. All right, moving on. I would have sworn I would have done that type of problem somewhere. I guess I didn't. Weird. Oh, no, it's this problem, number 13. Just in terms of radians. Okay, number 19. Now this is probably by far the hardest problem on this review, so we're going to go through this kind of step by step. So I'm going to add 1 to both sides and then divide by 3. So I'm at tangent squared of 2x is equal to, well, 3 also. So 1, divide everything by 3. So I get tangent squared of 2x is equal to 1/3, square root both sides. So I get tangent of 2x is equal to plus or minus 1 over square root of 3, or you could also write that as root 3 over 3, whichever one that you're more comfortable with. Now, I'm going to do this in terms of pi. So like I did before, I'm going to change this over to be a. So I'm going to say a is equal to, now this is plus or minus with the 1 over root 3. So that's 30 degrees normally, so that's going to be pi over 6, 5 pi over 6, 7 pi over 6, and then 11 pi over 6. But since this is double that, I need to take all of these values and then in a sense double them again. So add by 2 pi. So the bottom number is 6. So I'm going to add the top by 12. So this is going to be 13 pi over 6. This is going to be so I actually think I did same. Okay, so 17 pi over 6. This is going to be, and actually you can kind of see a pattern here. So this is 4, this is 2, this is 4, this is 2, this is 4, then this is going to be 19 pi over 6, and then to finish this up 4 from there, so 23 pi over 6. Okay, and then since we're now going to change this over to be not a, but 2x, divide everything by 2 or multiply it by 1 over 2. And so your answer is going to be pi over 12, 5 pi over 12, 7 pi over 12, 11 pi over 12, 13 pi over 12, 17 pi over 12, 19 pi over 12, and 23 pi over 12. And those are all my values. Hope you enjoyed this video. Thank you very much.